one-time table and electric current when lighting discharge static electricity, transfer a great deal of electric charge all at once. Such a sudden and large discharge of electricity is useful. You can plug a toaster into a lightning bolt to power appliances and other electric devices. You need a source of electricity, provides a relatively small amount of continuous flowing electric charges. The solution is an electric current. What is electric current? Electric current is a continuous flow of electric charges. Current is measured as the amount of charge that flows past a given point in a certain amount of time. The SI unit for electric current is ampere or amp. Electric current may flow in just one direction or may keep reversing direction when current flows in just one direction. We call it direct current. Current that flows through a battery-powered flashlight is a direct current. Current keep reversing direction is called alternating current. The current that runs through the wires in your home is an alternating current. Water charge is flowing in electric current, and it has to do with electric potential energy. Potential energy is stored energy and that an object has due to its position or shape. Electric charge has potential energy because of its position in an electric field. For example, two negative charges close together, they have potential energy because they repel each other and they have potential to push apart. If the charges move apart, the potential energy decreases. Electric charge also move spontaneously from a position where they have a higher potential energy to a position where the potential energy is lower, similar to water falling over a dam from an area of higher to lower potential energy due to gravity. In general, for electric charge to move from one position to another, there must be a difference in electrical potential energy between the two positions. Difference in electrical potential energy is called potential difference. Voltage is measured in a SI unit called volt. For example, the terminals of a car battery has a potential difference of 12 volts. The difference in voltage results in dependent volt of charges. Electric current, what is source of voltage? Battery are one of the several possible sources of voltage to produce electric current. Sources of voltage include generators, chemical cells, and solar cells. Generators can change kinetic energy of a spinning turbine to electrical energy, a process called electromagnetic induction. Chemical and solar cells are devices that change chemical or light energy to electric energy. What is chemical cells? Chemical cells are found in batteries. They produce voltage by means of chemical reactions. Chemical cells have two electrodes, which are straps made of different materials, such as zinc and carbon. The simplest type of battery contains a single cell. Electrodes extend out of the battery for the attachment of wires that carry the current. Electrodes are suspended near electrolyte. The electrolyte is a substance containing free ions that can carry electric current. Electrolytes may either in paste, which cast the cells called a dry cell, or liquid, in which case the cell is called a wet cell. Flashlight battery contain dry cells, car battery contain wet cell. Both dry and wet cell work in the same basic way. The electrodes react chemically with the electrolyte, causing one of the electrode to give up electron, the other electrode to accept electron. In the case of zinc and carbon electrodes, the zinc electrodes attack the electrode and become negatively charged. The carbon electrodes give up electron become positively charged. Electron flows through electrolyte from the negative to positive electrode. Wires are used to connect the two electrodes, the terminal ends. Electric current will flow through the wires and can be used to power a light bulb or the electric device. What are solar cells? Solar cell conversion energy, sunlight to electrical energy. They contain material such as silicon that absorbs light energy. Think about electrons and electron flow and create electric current. Solar cells also called photovoltaic cell because they use light to produce the voltage. Contacts in PV cells are like the terminal in a chemical cell. One contact is negative and the other contact is positive, creating a difference electrical potential or voltage, which produces electric current. Also, the cell uses light energy to produce energy. Electric current that powers a light bulb. Many calculators and other devices are also powered by solar cells, with its electric current and materials. Electric current cannot travel through empty space and need a material through which to travel. However, when current travels through a material, the flowing electron collides with a particle material. This creates a resistance. What is resistance? Resistance is the opposition to the flow of electric charges that occur when electric current travels through matter. The SI unit of resistance is ohm, named for the scientist ohm. Resistance is caused by electron and current bumping into electron lags in the matter through which the current is flowing. Resistance is similar to the friction. Resistance is similar to the friction that resists the movement on the surface as a slide over another. Resistance to the amount of current can travel through material because some of the electrical energy converted to other forms of energy. For example, when electric current flows through a tungsten wire inside an incandescent light bulb, the tungsten resists flow of electric charges, and some of the electrical energy is converted to light and thermal energy. What is electrical conductor and insulators? Some materials resist the flow of electric current more or less than other materials do. Materials that have a low resistance to electric current are called electrical conductors. Many metal contain copper, aluminum, and steel are good conductors of electricity. Water have even a tiny amount of impurities and electrical conduction as well. Materials that have high resistance to electric current are called electrical insulators. Wooden, rubber, and plastic. An example of an electrical insulator Paris is also an electrical insulator. Probably know that electrical wires are made of metal, for example copper, could use rubber or plastic. Now I know why. These are good electrical conductors. They offer little resistance and allow most of the current to pass through. Rubber and plastic are good insulators, so they offer a lot of resistance and little resistance to pass through. More than one material is available for the electric current to flow through. The current always travels through the material that's with the least resistance. That's why other current passes through metal wire now flows through its rubber or plastic coating. What is property that affect resistance for a regular material? The property of a material determines how resistance to electric current, that's width and temperature. Longer wire have more resistance. Current must travel further, so there's more chance to cloud the particle wire. A wire have less resistance. Given amount of current has more room to flow through a wider wire. Cooler wire has less resistance than a warm wire. Cooler particles have less kinetic energy, so they move more slowly, because they're less likely to collide with the slow moving particles. The material called superconductors have virtually no resistance when they are cooled to extremely low temperatures. What is Ohm's law? Voltage or difference in electrical potential energy is needed for electric current to flow. As you might have guessed, greater voltage results in more current. Resistance, on the other hand, pulses the flow of electric current, so greater resistance results in less current. So this relation between current, voltage, and resistance was first demonstrated by German scientist named Georg Ohm in the early 1800s. This is referred to Ohm's law. Ohm's law can be represented by the following equation. Current equals voltage divided by resistance. How to understand Ohm's law? You might have a better understanding of Ohm's law. Compare current flow through a wire from battery to water flowing through a cotton hose from a tap. Increasing voltage is like opening the tap wider. Tap is open wider, more water flows through the hose, like an increase in current. Stepping on the hose makes it harder for water to pass through, so that increasing resistance causes less current to flow through material. How to use Ohm's law to calculate current? You can use the equation for current above to calculate the amount of current flowing through material when voltage and resistance are unknown. Because there are an electrical wire that is connected to a 12-volt battery. The wire has a resistance of 3 ohms. How much current is flowing through the wire? Current equals 12 volts divided by 3 ohms equals 4 amps. And make a summary. Electric current is a continuous flow of electron charge. It is measuring amperes throughout the current. flows in just one direction, alternating current. Keep reversing direction. Electric current occurs whenever there is a difference in electrical potential energy. Voltage is measured in volts. Sources of voltage include electric generator and cells. Electrical generator changes kinetic energy to electrical energy. Chemical cell changes chemical energy to electrical energy. Solar cells change solar energy to electrical energy. Electrical current is a material through which to travel, but the particle of the material may resist flow of current. The material differs in how much they resist the current. Material with low resistance are called electric conductors, and material with high resistance are called electric insulators. According to Ohm's law, current increases when voltage increases when resistance decreases. Current can be calculated as voltage divided by the resistance as is given by. One-time G scale Mozart and Haydn concerto in G major.